Okay, so in this video, we are going to discuss about one of the important operator in programming, that is the modulus operator. You see this. This is a symbol for the modulus operator or the modulo operator. So this operator is very much common in programming and obviously in cryptography and all. So what is this operator and what does it does? So this operator when acts upon two operand and gives the remainder of the division. Okay, so how does it gives the remainder of the division? Like if you do 5 modulus 2, then it will be something like we are dividing 5 by 2 and then we are getting this 1 as the remainder. So this operator will give a result of 1. So I hope this is clear from this. What does this operator does? It gives the remainder when one number is being divided by another number. It provides the remainder of the number. For example, 4 modulus 2 is 0. Of course, because 2 completely divides 4, we are getting 0. If we do 1 modulus 5, then we are getting the remainder as 1 only because we can't divide 1 by 5. The numerator is only our modulus. Okay, so these are the basic things, right? So now let's see how this modulus operator is being used in programming. Before that, I would like to tell you about three important rules that you need to take into consideration before doing this modulus operator. Okay, before doing computation on this modulus operator. So the very first rule is modulus always gives numerator sign. Modulus always give the numerator sign. Very important. These three rules are very important to be kept in mind when we are doing this modulus operation. Numerator sign. For example, 5 modulus 2. What is the sign of 5? 5 is a positive number. Then definitely the result, that is 1, is positive only. So modulus always give the numerator sign. It won't be minus 1. Okay, it will be plus 1 only. This plus is hidden somehow. Okay, so this remember, if it is minus 5 modulus 2, then it will be minus 1 all. Why it is minus 1? Because this 5 is a negative number. This is our numerator. 5 upon 2. This is our numerator. Okay. So this modulus operator always give the numerator sign. This is the sign of numerator. Is it clear? This is the very first rule. The second rule is modulus does not work upon the floating point number. Okay. Very important. Modulus does not work on float values, or you can say floating point numbers. Very important. Okay. And the third point is if the value is small, if the value is small, that is the numerator is smaller than the denominator. If the value is small, in short, you can understand is if the numerator is smaller than denominator. Okay, I have written a long sentence, but it is simple matter of sign. Okay, if the numerator is smaller than denominator without sign, without sign means it is a positive part. Without sign, then it gives the same value as the output. Same value as output. Now, understand this part is when the numerator is smaller than the denominator without the sign, then after applying the modulus operator, we are getting the same numerator as the output. Okay, so we are going to see all these rules in the below examples. For example, let's say we have 15 modulus 7. Okay, 15 modulus 7. So the remainder when 15 would be divided by 7 will be 1. And since this is the numerator and it is a positive number, we are having the same sign as the numerator. Okay. Now if it is, let's explicitly mention it as plus 1. Okay. Now if it is minus 15 modulus 7. Okay, so it will be minus 1. Why? Because the modulus operator gives 1 and the numerator is having a negative sign in front of that. So the output will also have the negative sign, same as the numerator. Okay. Third one, let's say if it is plus 15, we are explicitly mentioning the sign of the numerator here, then it will be definitely plus 1. Okay, it is same as the first case. But if it is plus 15 modulus minus 7. Now see, this is the denominator. So if the numerator is having the positive sign, then we don't need to see the denominator. Obviously, the sign would be plus 1 only. This is an important point to remember because this is the thing that is a key part of programming. The computer will do like this way. Okay. So if the numerator is having the positive sign and there is a modulus operator and we are having the denominator as a negative number, then our output will be a positive, same as the denominator, same as the numerator. Sorry. Then we have something like minus 15 modulus minus 7. Of course, it will be minus 1 because our numerator is having a negative sign. Okay. Then we have minus 15.5. It is a floating point number. So I already have in the rule that if any of the operand is a floating point number, then we are going to get the error because modulus operator does not work on floating point number. So that is why I already mentioned all these three rules. Okay, so if it is minus 5 modulus 7. Okay, now you see this numerator is a smaller operand. I mean, the numerator is lesser than the denominator. So we have this rule 3 that if the value is small without sign, then it gives the same output as the value. Okay, so here minus 5 modulus 7. Of course, if it would be 5 modulus 7, what would be the output? 5 only. But the numerator is having a minus sign, so we are forced to explicitly mention its sign as minus 5 because the numerator is having the minus sign. Let's see if we have it as plus modulus minus 7. Then also we are getting the output as plus 5 because the numerator here is positive. Okay. And this is how it goes, right? For the third rule. Now, these are some of the examples, but the three rules that I already mentioned here, what are these three rules? Modulus always take or give the numerator sign. Okay, modulus does not work on floating point value, and if the value is small without sign, then it gives the same value as the output. Okay, so these three things that needs to be considered while evaluating any expression. For example, if we have an expression like 15.0 divide by 2 into 2 modulus 7. Okay, so first of all, we have already learnt about the precedence and associativity of the operators. So you see here we have these three as the same precedence, right? In the precedence table. So we need to follow the associativity. So we are going to evaluate the expression from left to right, right? So 15.0 divide by 2. So what is this evaluation? It will be something 7.5, right? So it will be 7.5 into 2 modulus 7. Now this star and this modulus are having the same precedence. Again, we are going to follow the associativity and it will be 7.5 into 2. This is a floating point number. This is an integer. So our output will be 15.0 and then it is a modulus 7. Okay, now this is a floating point value and this is an integer, so we are going to perform the modulus operation on floating point, hence it will give an error. So these kind of things that matter most in programming, because the computer understands this way, so it will give an error, but if you try to compute it as manually, you won't get error. So we need to understand how the computer understands the evaluation of this expression. Okay, so that is way it is a important thing to note. If we are getting the error, why we are getting the error? Because we are doing this modulus operation on this floating point number, and this modulo operator on floating point number is not allowed, so that is why we are getting error. Okay, let's see one another example for that. It will be, let's suppose we have this data type declaration integer, I is an integer. Okay, and we are assigning some values to it from this expression. This is an expression, we are assigning the value from this. Now this is a very long expression, we are evaluating this expression and assigning the value to this I. Okay, now first this evaluation needs to be evaluated. So you see here we have this all operators present in the same line, so we need to follow the associativity, left to right. 3 into 2 6, divide by 4 plus 2.0, then this divide by 5 plus 8 divide by 5. Now again this three division have the same precedence, left to right associativity, so 6 divide by 4, both are integers, so our value is 1. Actually, it should be 6 divided by 4 something in decimal, but we just have to take the integer value only from that. Okay, and then we have, because both of them are integer, right? We learned this in the very first part of the lecture. Then we have 2.0, then 5 plus 8 divide by 5. Now we are having this plus, then we have division, then division. These two are having higher precedence. So left to right again, 2.0 divide by 5. This is a floating point, this is an integer, so our value is 0.4 plus 8 divided by 5, again 1 plus 0.4 plus 8 divided by 5 is 1. Because both are integer, we are going to assign the integer value only. Okay, then we have this value as 2.4, and this 2.4 is being assigned to integer. So if you are asked what will be the value of I, what is value of I? So since I is an integer, it is going to take this part only. So I equal to 2, right? So this is how the first two lectures we talked about are important in programming, because these are the key concepts. You need to understand how the computer evaluates the expression, what values it assigns to, how the evaluation of the expressions and the operands are so important. So please keep in mind while doing programming in any of the languages. So this is how it is important. Thank you for your time. Bye bye.